Welcome to a Friday episode of Juan's World. I'm going to talk to you today about statistics. And I'm going to start with Mark Twain's famous statement. He didn't actually originate it, but he certainly popularized it. He said, there are three kinds of lies: lies, damn lies, and statistics. And that's a amusing statement, but it's not really fair to statistics, although it's fair to people who use statistics in nefarious ways. So I want to talk about how statistics are used well and how they're used badly, and I'm going to try to link it a little bit to my videos on change. Now, we all know that statistics can be used badly, and they are used badly all the time. They're being used badly right now in the political arena, in the United States and in Britain, and they're also being used badly when it comes to reporting about the coronavirus. Let's start with the coronavirus, since that's fairly current right now. You will hear statistics including how many people have the virus or have contracted the illness. And what you won't hear are the background information necessary to interpret what you hear. So if you're told a statistic such as that, 80 people, 400 people, whatever, have been confirmed to have the infection. Well, what you need to know is how many people were tested. It's not okay to just say 420, 1,000, whatever number you pick out of a hat. Whatever number of people have been confirmed to have the virus is dependent on how many people were tested. There could be a raft of people in the United States with the coronavirus, but they haven't been tested because there are protocols in place. The protocols, at least until recently, said if you have not been out of the country or to certain countries or been in contact with people who have been to those countries, then you don't get tested. One of the reasons they don't test everybody is they don't have enough tests. They need to use the test sparingly. So there could be a whole raft of people, thousands of people possibly, who have flu-like symptoms, fever, sore throat, coughing, difficulty breathing. But they just think, I've got the flu, and then they don't get counted. So in that respect, the statistics are skewed. And that's a big, big, big problem with statistics in general, is that how you sample a population is going to determine how accurate or useful your statistics are. Now let's take another example. Let's take political polling. We know of several instances in the not distant past where polling has been proven wrong. For example, all the polling except a few outliers and the internal polling of the Trump organization, all the other polling said that Hillary Clinton was going to win. And in fact, she won the popular vote. She did not win the presidency, even though the polling was in her favor, for several reasons. One of them is that the samples were not accurate. Another is that they weren't sampling according to the way the Electoral College works in the United States. They were just polling in terms of popularity. And she did have more than 50% popularity than Donald Trump, but that didn't get her over the winning line when it came to the Electoral College. So that kind of polling was skewed anyway. It can also be skewed in terms of the sample that you choose, both who you choose to sample and how many you choose. It's very important when you're looking at statistics of political polling to see how many people they polled. If they're polling for a national election in the United States and they've polled, let's say, 500 people or 1,000 people even, that's not a whole lot. You've got somewhere in the range of maybe 100 million people eligible to vote who will vote, and 1,000 or even 2,000 people, not a whole lot. So a small sample size can be skewed. Also, a sample can be skewed if it relies on certain methods of collecting the information. If you, for example, telephone people and ask them if they want to take a poll for political reasons, depending on the kind of phone you use, home phone for example, then there are going to be a lot of people you're going to miss who don't have home phones. I don't have a home phone. Or if you use smartphones, there's a lot of people who screen their calls. I do. I don't answer the phone if it's not a number I recognize. So either way, if you use phone methods, you're going to miss a certain group of people. If you approach people on the street, you're going to miss a lot of people. Sorry to keep mentioning myself, but in all of those cases, you're going to miss me. I don't answer surveys on the street. So polling statistics always have a margin of error. You're going to calculate how wide that margin is going to be dependent on your sample size, the method of sampling, and so forth. But in all those cases, your statistics can be wrong. Now, when it comes to your health or medicine in general, you really ought to pay attention to statistics. If, for example, statistics tell you that you have let's say, 60% chance of developing respiratory or cardiac problems by smoking, then you really shouldn't be smoking. And of course, that's one of the reasons I have quit smoking cigars, even though I used to only smoke about 1 or 2 a week, and I didn't really inhale, so wasn't in any great danger. But even so, let's just say that you've got a 60% chance of getting some kind of damage to your lungs or to your heart or your blood pressure or whatever if you smoke. Then it's a good idea not to smoke, even if it's only 60%. You could say, wow, gosh, 40%. Do you want to take those odds? A lot of people will say, well, I'm going to keep smoking. I had an aunt who lived to be 98 and she drank whiskey and smoked every day. But anecdotal evidence doesn't help, and that's the point about statistics. You're relying on a kind of gamble, if you will. You're saying, yeah, I'm not sure that I want to risk 60%, or probably higher than that in terms of potential mortality rates over a long period of time. But what about really small numbers? Now this is where it gets interesting, and we'll go back to the coronavirus. On average, it looks like about 2% of the people who contract the coronavirus die. Well, it goes up a little bit if you've got underlying conditions that exacerbate the illness, or if you're just older, therefore have a weaker immune system. But let's just take 2%. Should you be worried if you contract the coronavirus and there's a 2% chance of dying? Well, I'd say no, you shouldn't really worry too much. And this is how you put it in perspective. Think about a deck of cards. A deck of cards has 52 different cards in it. So if you name a card, say 2 of spades, and then you go to a deck and face down you randomly pick a card, what are the chances that you're going to pick the card that you named? You named the 2 of spades. What's the chance you're going to pick it? It's 1 in 52, or 2 in 104. That's about 2%. So your chance of dying from the coronavirus is about the same as naming a card and then picking it from the deck. It's not that much. So I would say on the whole, therefore, if you get the coronavirus, don't panic, especially if you don't have other health problems. That's how you put numbers like that in perspective. But let's now take another 2%. Let's say this isn't of course true, but let's say you have a 2% chance of dying in a crash if you go on a commercial airliner. Well, now, commercial airlines would go out of business really quickly. Let's say you go on, we'll call it Unlucky Airlines. Unlucky Airlines crashes 2 times every 100 flights. You're not going on that. You don't want a 2% chance of crashing. That airline's going out of business. You want something like 0.00001% chance of crashing. Right? So you've got to put these percentages in perspective. Now, I'm a social scientist, and social science uses statistics an awful lot. I don't in my work because I am a different kind of social scientist. I believe in using what they call qualitative research rather than quantitative research, because by participant observer fieldwork or interviews or life histories or photo documentation or various forms of qualitative analysis, I feel get at fine-grained details in ways that quantitative analysis does not. But this is one thing I do know as a social scientist, and that is that the modern world runs on statistics. whether you like it or not. Like whether you want to accept a medical practitioner's advice based on statistics, whether you want to eat certain foods because of statistics and avoid others because of statistics, that's up to you. But what I know for sure is that everything that is marketed to you, every politician that you see, has been using statistics to give you information. When a new soap or shampoo or breakfast cereal is being marketed, you can be absolutely sure it's been market tested using statistics, and there have been determinants as to what works and what doesn't work statistically. Same happens often with movies. Movies can be on minimal release, and then there will be an analysis, a quantitative statistical analysis, and it will be determined, well, that character is not so popular, so we'll edit him or her down or out. This character was extremely popular, surprisingly, so we'll edit him or her in a little bit more, and so forth. When you are watching a long-running TV show, you can be sure that there's a statistical analysis of plot devices and arcs that work and ones that don't work. When you see a politician debating or giving a speech, you can be sure that they have tested statistically what they're going to say, how they're going to say it, and what they're going to promise or not promise, depending on their statistical research. All of these areas of our lives are governed by statistical research. And of course, sometimes they're wrong. Sometimes a new breakfast cereal comes out and it tests well in market research, the statistics all look good, and it flops. Same with a movie, and of course, same with a politician. Because the ultimate statistic for a politician or for a breakfast cereal is the consumer as a whole. The thing is that statistical analysis is a sample of the whole. But when you go to the polls, admittedly in states like the United Kingdom and the United States, they are still samples, but the law gives the thumbs up to the person with the most votes, even if they're not the majority of the people in the nation, because so many didn't vote. In places like Argentina and Australia, things are a little bit different because their voting is mandatory. And you get fined if you don't vote and don't have a really good excuse, like being in hospital or being abroad. I haven't voted in Argentina now for going on for 7 years. And when I return home, I'm going to have to prove that I was away during voting time, otherwise I'll have to pay a hefty fine. Now in those cases, then you've got close to 100% representation with some little bibs and bobs that kind of skew things a little bit, but not much. You know, for example, when I go to the polls in Argentina, I actually don't vote. I don't cast an actual ballot. I do some things so that I can officially abstain, but I have to go there. And other people do that. A few other people. But you're getting the 100% cooperation in some way. You're not sampling anymore. And so there may be a difference between what actually happens when everyone gets the chance to vote or to choose a breakfast cereal or to go to the movies. When you've got the whole population deciding, then your sample size or the particular sample you've chosen may be so badly off that you fail. That's one of the problems with statistics. But you cannot chide statistics in the way that Mark Twain does. You can't just say that statistics are by definition worse than damn lies. They're not. They're useful in a lot of ways, and we use them all the time in a lot of ways. But sometimes they're used badly. They're used to obscure things. Sometimes they are misinterpreted. And sometimes the results are not what we would like, and so we tend to ignore them. There's all these kinds of reasons why statistics are not always beneficial or used well, but they are not in principle bad. I'm going to keep working on this next Friday as well, and I'm going to talk a little bit about change and statistics. But for now, I would just ask you to like and subscribe, and I will see you on Tuesday with a new recipe.